Alright, should be a live video shortly anyway, and such. So I thought I would do a charge video, just because I haven't done one in a while. And it's probably, of all that I'm arguing in physics, this is probably the most important discovery, that probably would have been discovered again if physics didn't get all sidetracked with its wavy, wooey, living force kind of perception of how force and matter interacts, and especially, I guess, the idea that force isn't something, that somehow you could have a bent geodesic that moves things, and that the forces are all ambiguous and singularing and superimposing and interfering and all kinds of crap like that. So anyway, the basic model is this: there's two kinds of force, electron force and proton force, and then there's two kinds of matter, protons and electrons. And this is what, after the simulation runs a little bit, is what it ends up doing, which is creating red green things. It starts creating dipoles, put simply. And so let's see which one of these is the right. This one? Nope, that didn't work. Oh. Freeze. Great, fantastic. Nothing like having the computer freeze right in the middle of a video. Yeah, thank you. Oh, let's see if it's going to be salvageable. Doesn't look like it. Yeah, I don't know what it's going to do. Well, we'll wait and see, I guess. We'll find out. So if I restart the simulation, maybe the simulator is a little bit hard on the browser, so maybe that's what the problem is. Well, whatever the problem is, it's rather severe anyway, so can't do both things at once. So that's how it starts, and it will, oh brother, yeah, it will. Maybe it won't. It's going to be interesting to see what this video turns into. Yeah, well, it's not going to turn into anything good, apparently. So Warren Buffett you don't need. So we'll get rid of him. And we'll see if the video catches up now. It looks like it did. Okay. So we'll go to drawing. Alright. So it's the old version of the simulation. Maybe it was taking up more resources than they usually do. So, I mean, I used to be able to play it without it blowing up like that. So, YouTube not receiving enough video to remain smooth streaming. Okay. Yeah, so everything's going wrong. As such, viewers will. What will they experience? Doesn't say. Open widget. What the hell's... I don't know if I want to open a widget. I hate when there's error messages that are just useless. Ugh. Alright, I'll open a widget. Experiencing buffers. Yeah, well, okay, that already happened. You should be back to normal by now. Oh, God. So annoying. Alright, let me see if we still have a microphone. Yes, okay. Now it keeps saying it. It can't be poor. It's just lying to me. It's lying. Alright, it doesn't allow me to change them there. Alright, what do we do? Give up? Yeah, maybe that's the thing to do. Yes, give up. I uncapped my markers and everything. Alright, so false alarm. Probably. Hello. Alright, forced reality. How is the video quality? Can you see the video? Does it play? Shall I continue and ignore the errors, or shall I start over? Answer, please. Answer, please. Answer, please. Yeah. Okay, the quality is good. Okay, then I'll just ignore the bullshit from YouTube. Alright, so back to where I was. Yeah. It's real life, sorry, technology, blah, blah, blah. Alright, so the simple principle is that the force is the stuff moving the speed of light, okay? And it's made out of little bits, and you can imagine that a photon would be little bits at a frequency, and if you want to get really technical about it, it's little bits at a frequency and a polarization. That is, they're traveling in line with each other, but they have this as a polarization and this as a period, okay, between events or frequency or wavelength or whatever jargon you prefer. And the basic idea is that yes, you have two kinds of force, two kinds of matter, and so we'll put a little red one here just for the fun of it. And so the simple argument is with just three interactions you can explain everything that happens between electrons and protons. So the simple argument is if an electron, say, wasn't moving, alright, or it's moving in, say, the same direction as a force bit will hit it, then the force bit will stick. And so more than one can stick. So, you know, it can collect them. And for each one that hits, say, let's just say it goes 10% of the speed of light. And, you know, it gets progressively less and less as you add more and more, because you can never go as fast as the pusher. So it's, you know, the next one would be, you know, 9.9%. The next one would be 9.8%, and so it would just keep going down and down in terms of the percentage increase. So the first few that hit, you get a big increase in your velocity, and after you get 10 or 20, you start getting a very small increase in your velocity as you acquire more and more force. And so that's what's seen in experiments where they accelerate electrons. That's the phenomenon you see. In a sense, it's really easy to get them almost to the speed of light, but it's very hard to add energy later. And that's what Einstein says, well, that's because this particle is getting infinitely massive. And it's not getting infinitely massive, it's just that you can't push it faster than the pushers can run. So the force bits are essentially like a siphicus, okay? They're pushers, and the matter is basically a boulder. So you can think of the electron as a boulder and the force bit as something that pushes boulders. So now if the electron is moving in the opposite direction, that is, it has pushers already going in this direction, and then a bit hits in the forward direction against that motion, well, that bit will reflect, and one of these little extra bits will reflect. So it'll lose 10% of its velocity around, and the other bit will reflect. So, you know, it's perfectly conservative of the momentum in the sense that you've done what you would expect. That is, you've taken a little bit of this one's momentum away. You've reduced its MV. Alright, so those are the two possible interactions. The sticking and adding force, and the reflection, which subtracts whatever force it has. Alright, and obviously it can happen at angles, and it gets a little more complicated, but you're really just talking about any vector, you know, any vector that has a portion in this direction. So that's, you're really just exchanging energy in with any portion in the right direction. Alright, now the tricky one is, the one that makes it all really work, is the fact that if a proton force hits an electron, it just goes straight through, doesn't cause any motion, and it just pops out an electron force. So the siphicus changes color, okay, when it goes into the opposite material object. So with those three interactions, absorption, reflection, and that simple transition, you end up with a circumstance that perfectly duplicates Maxwellian charge, in the sense that you could sort of understand that because all the blue stuff that hits the red thing will turn red, and it can only reflect red, then it's just going to radiate red. Okay, so it doesn't have any force of its own. All it can do is reflect the world that it interacts with. So the proton will look like a little red radiator, okay, and the electron obviously will look like a perfect blue radiator. Alright, and I'm doing this with these lines of force, that what Maxwell called them, because it's really about the intersection of these lines of force that creates the inverse square law. Now in 2 dimensions it's not going to make the inverse square law, but in 3 dimensions it will, because you're going to, as the force goes out and reflects, it's expanding in this direction, and it's also going to expand in that direction. So it's going to be dissipated by the inverse square law, just because of the fact that the particles are going to move away from each other in both dimensions, in this way and this way. So obviously that creates the square. Alright, so it gets weaker quadratically, essentially. So now the point is that you could sort of understand that if an electron and a proton are near each other, you could understand that no red force coming from this direction can't get to this proton. So it can't get hit with red force from this direction. It can only get hit by red force from this direction. So one side is going to get hit more than the other side, okay, because everything red is going to turn blue, and so it's only blue bits, and the blue bits are going to go straight through and just turn red again. So it's going to be like it didn't hit anything at all. A force bit red hitting a blue and then going through a red again will just come out red, and it'll be as if nothing happened to it at all. And all the blue force, of course, will be pushing on the electron, okay, and all this red force will be pushing on the proton. And you can understand that because there's going to be no blue force hitting here and no red force hitting here, that there's going to be a very low pressure here. Okay, there's going to be very few particles that can hit and be absorbed or reflected. So instead of any reflections or any absorptions, there's going to be nothing in between them. So obviously there's going to be a very strong force pulling them together. And in the inverse case, I suppose I can squeeze it down here, where you have, say, an electron and a, well, we'll use an electron because this pen has better ink, an electron and an electron facing each other. You can understand that now all the red force from the outside here and all the red force on the outside here is going to be converted into blue force. So there's going to be a ton of blue force here, extra blue force here. So obviously now you've got a tremendous amount of pushing force, because all of the reds are now turned into blues. The blues do stick, the blues do reflect, so they're going to obviously give both objects momentum away from each other. Now obviously the same thing happens when you have proton and proton. Now I would argue that this is a profoundly significant scientific discovery, in the sense that this is so simple and it duplicates charge, which physics has no clue about. And even to the point that they have no clue, I hate to erase, but well, maybe I can go this way. Yeah. All right. Their cluelessness goes to the point where they invented a thing called the strong force in nucleuses, because they're claiming, oh, they can't get, two protons can't get close to each other. They obviously know they have a tremendous force of repulsion, and they think they need some new force to push them together, when the obvious answer is the neutron. The obvious answer is, if this was a neutron, okay, a proton and an electron stuck together, you could understand that now it's really easy to get two protons really close to each other. You just add another proton to the neutron. They call this a deuteron, actually, which is interesting. They actually have a term for something they don't believe exists. But it demonstrates that the nucleus, the protons, have to be understood as a dipole, as an electron and a proton. And physics absolutely knows that this neutron decays into an electron and proton. That is, it turns into an electron and proton when you extract it from a nucleus. So why would they pretend that they can't figure this simple arrangement out and say, okay, now I can understand how a proton can get close to a proton? And you don't need anything called the strong force. The strong force would be a silly statement to make when you have this obvious mechanism. Now, you could know this back in Maxwell's day, right? So even in Maxwell's day, you knew charges, that if you had two positive charges, you could stick a negative charge between them, and you could get the two positive charges very close together. I mean, that's just basic magnets even do. We'll show you that. So this isn't even complicated. I mean, you know, you could take the north end of a magnet and connect two south ends to the north end of a magnet, and they'll be very close to each other. You know, and that's the way you could do it. And then you could understand that if you could knock that out very quickly, if I could knock that electron out of there by hitting it with force, then all of a sudden I'd have two protons right next to each other. I'd be doing this here, you know, down here at the bottom, creating a tremendous amount of force between them, because all the blue bits would be turning into red bits between them, and there'd be tremendous force pushing them apart. So it fits their own data exquisitely, okay? It perfectly duplicates Maxwell's diagram of the function of charges, and it's dirt simple. I mean, two kinds of force, two kinds of matter, three interactions. You can't get any simpler than this. And, you know, so I've been talking this for 5 years at least, and, you know, provided simulations. You know, the simulations aren't perfect yet, but they clearly do exactly what I'm claiming this does. You can't mess this up, right? I mean, the math is so simple. So, you know, the simulation is accurate to everything I'm saying here. It's just creating those three interactions. And it works. It happens. It creates the objects I'm describing, and those objects are what nucleuses are made out of. And it's and now you know, you can also say, well, once you've created the first dipole, the neutron, you know, as long as you understand a neutron is a dipole, well, now you can understand where magnetism comes from too. That arranging those dipoles in the same orientation would end up creating a circumstance where you're going to create more red, you know, a mixture of red and blue, where it's more red and less blue, and then the other side's going to be more blue and less red. You know, so you're creating that polarity that is the basic mechanism of magnetism. And so, so yeah, I don't, you know, it's hard to do this video in 5 minutes. So that's sort of what this is practice for. But I still am amazed at how little any reception whatsoever, any kind of indication that people can say, yes, that model does work. It's a simple fact, it does duplicate charge. And what exactly are its huge liabilities, in the sense of how exactly do you say it can't be true? You know, what vital thing do you have to include? Now, you know, obviously this eliminates the need for the strong force, so it obviously eliminates the need for gluons. It obviously eliminates the need for the 400 other strange particles they say exist. Now, but it also explains why those particles exist, because we can't see this red force in action. We can see the blue force because that's the one that affects electrons on the surface. So that's the one that radio waves and photons are doing. Photons are blue force tons, okay? But we don't see any of the red force, because that one only moves protons, and protons are only in nucleuses. And obviously nucleuses under a tremendous amount of pressure, that's what holds them together. So they're hard to jiggle, they're hard to break. So that's why we don't see any of this red stuff doing anything. But it's clearly elemental to the function. Without it, electrons can't repel each other. You know, and everything stops working without that red force. But that's the real the real story is that physics assumes it can see everything. And so what it's seeing is it has a cloud chamber and it sees some particle all of a sudden poof out of nowhere, and it says, okay, a force must have created it, or some other particle must have created it. And they assume, because of their inverse square law thing, that energies are always this quadratically increasing with velocity thing. So they exaggerate how much energy caused the effect, and they exaggerate how much energy was created in the effect. So this is why mv squared is important to debunk, is because all of their nuclear physics has it all distorting all of the energy values, and therefore they keep thinking there must be some other neutrino that they're not seeing, or some antimatter, or some other ghost particle has to be the cause of something, because they're exaggerating the function. Now this could be seen in the invention of the positron, because the positron experiment, the one that led to the discovery of the positron, was done by a half dozen people, and 5 out of those 6 people didn't see a positron. They saw a weird proton. They didn't see a positron. So the very fact that it's just a label put on something based on a bunch of rules they've created saying about how much energy something must have to do a certain thing. And so you can understand that maybe all that is mush, and that you don't have to believe there are taus and muons and all of this other stuff, because it could just be a combination of these objects being pushed, all right, 2 electrons pushed in the same direction. They would push on each other. That would be a simple explanation for a muon, for example, is that you just have 2 electrons moving, okay, with force behind one of them pushing it into the other one, and that they would look like they might decay, in the sense that eventually the force runs out and the 2 electrons go their separate way. But so I don't know what to say, right? There's just no way to get an audience for what I would argue. Like I said, even if you think this is wrong, the fact that it explains something as complicated as repulsion and attraction in the same system with a model this simple. You're not going to get anything simpler than this that can make electrons repel each other and make electrons attract protons. It just ain't going to happen simpler than this. So it just shows that this is an audience problem. This is a human, it's hard to say what the problem is, but I shouldn't have to sit there and make videos for 5 years explaining something this unique, this profoundly simple, wins the Occam's razor by a million miles, that actually works and perfectly duplicates something like Maxwell's drawings. This is what Maxwell drew. Maxwell talked about lines of force. Faraday talked about field lines. Okay, they're 2 different things, and I think Maxwell knew that these are radiators, and that those field lines are arbitrary. The lines you create around a magnet with iron filings, you can make those lines show up anywhere. They'll always be proportional, but you can make them very small, very thick. You can have big distance between them, small distance between them, just by changing what size iron particles you use. They're not defined lines in space. They're lines created when you create little magnets and throw them into the area of the magnet. And so they're they're not some kind of thing the bits are actually creating. They're just the idea of their position will dictate how strong the field is in these different positions, and whether something will stay there or not. And that's all it's about, whether the 2 fields are balanced. And that's where the iron filings end up staying, is where the fields are balanced. And the fields are balanced because every line of force you create around a magnet is the same orientation. All the lines are north-south, okay, in the same direction. So you can understand why there's lines in the first place. Obviously, these 2 lines can't crash into each other because they're essentially the same magnet. North-south, 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 north-south. They can't stick to each other because they're they have to be opposites to stick. So that's why they're lines, is because they're magnets. You've created a line of magnetism, and that line of magnetism, the two of them can't attract. And obviously any bits in between are going to choose one side or the other side. They're going to be closer to a stronger field, or they're going to be and further away from a weaker field. But it's just going to depend on how many iron filings have piled up on one will decide how close or far the other ones are going to be. I mean, it fits with so much of what they know for certain about. That's what I'm saying, is Maxwell is a sort of certain physics. I mean, it's, the rules are pretty certain, and it's creating exactly those certain rules. And that just seems like a hell of a coincidence that you have the simplest explanation. It fits and duplicates the rules perfectly. All right, and you're going to say, well, but it's wrong. It seems a reach to say in any default way it's wrong, because it doesn't include a strong force, because it doesn't have a muon in it, because there's no neutrinos flying anywhere. Therefore it must be wrong, because it doesn't have a bunch of eccentric nonsense in it. Alright, so let's go to the next, some of this crap. Hello, quality is good. It looks good, but are you trying to play a video? I don't know what that means. I'm not trying to play a video. I was running a simulation. Anyway, any experiments yet? LOL, just kidding. Whatever that means. Experiments can take some time to produce, especially considering variables. Well, decent experiments should take a very long time. That's the whole point. And again, it's not my job, so don't think that tomorrow I'm going to start doing experiments. Because frankly, it's not my fucking job. I mean, how many ways can I describe to you how I don't have any space? I don't have much in the way of materials. Why should I be doing experiments? Too silly. Physics has had 350 years and trillions of dollars. You don't think they should have done any of these experiments? They've had space shuttles, they've had zero gravity, they've had all the perfect environments to do them in, and they've done none of them. Alright, anyway. Oh yeah, the variables. Got to consider those. So many variables in a pendulum collision. Well, it really does, Newton pointed out, there's stuff that's really elastic and stuff that's not so elastic. So there are real variables. So you want to pretend it doesn't matter, fine. And exactly how are you going to measure things like velocity with a pendulum experiment? You have some great way to do that? You have those tools? I certainly don't have them here. I mean, just be an asshole. Well, it's your nature to be assholes. Obviously, none of this is actually on the subject, is it? No, you can't stay on the subject either, can you? It's just so pathetic, these silly, trolly asswipes. I mean, just get what you fucking deserve. I mean, I just wish, I would hope, again, that the future would recognize that these are the assholes that stop progress. They stop the human race from becoming wiser and more intelligent. These assholes are the problem. And they need to be pissed on for eternity. We need to make a permanent pissing machine just in case we're extinct, that it can still continue to piss on their lousy, stinking graves. They're a disgrace to human intelligence. They're a disgrace to our 100 billion neurons, because all they can do is talk shit. All they can do is wield a hammer. They can't build anything. They can't think rationally. They can't be imaginative. They can't do a motherfucking thing that's useful except break things. Alright. These electron videos are boring. Well, guess what? You're just going to get blocked. Fuck you in the ass till thoroughly dead. God damn it. Fucking cunt. I make one a month. Damn. Alright. God, I would actually like to see him talk about Maxwell's equations. They're not that complicated. He's just measuring the amount of force that affects objects based on their distance from each other. Is there something else happening in those equations, you fucking dumb cunt? No. Oh, God. Fucking people. Just amazing. Amazing bullshit. So again, you can show them a simulation of it working. It creates the inverse square law. It perfectly duplicates the function of electrons and protons inside of nucleuses, and that's the best they can do. I mean, really, it's just so obvious. They just can't stand the idea that the truth is something other than their wooey fables. God, I hate this planet. I mean, not an honest viewer can be had. You know. I mean, yes, there's whatever, 6 of you. 6 viewers in 5 years. That's it. Not one of these dissenting little Weasley cunts can admit the obvious. The obvious is this works. The obvious is it's really dirt simple. The obvious is it's really mechanical. I mean, there's no woo in it. There's no, oh, here I have to make up some kind of function. You know, the functions are so simple. I mean, absorption, reflection, transition. It's so fucking simple. Anyway, well, I did the job. I mean, I explained it. They can't hear, they can't listen, they won't pay any attention. There's not much else I can do. So, I guess I'll leave it at that. No useful interaction to be had. Just really, really depressing. Humans are just such garbage. Such garbage. Yeah, I'd be better off, you know, if we could, you know, make a lizard language capable. I'd probably get a more reasonable interaction than you can get from these human monkeys. Alright. So I guess I'll just get the hell out of here.